All right, we're going to start talking about React. Make sure you do attendance thing on website. Even if you don't have internet, I'm sure you can figure it out.
Got it. You got the hotspot.
So we're going to just start off a basic introduction on how you typically would do like a website. You basically started, you had JavaScript, and that was it. But JavaScript is much more annoying to work with. It got very verbose very quickly, very confusing very quickly. So eventually some smart people made Jquery, which basically takes a bunch of JavaScript stuff and makes it into a bunch of functions you can call so that it simplifies the process of working directly with HTML and manipulating the website and stuff. But jQuery, while it was much better than just using JavaScript, it still had some downsides. But eventually, they made frameworks like React, Vue, and Angular. We're not going to talk about those other two, though, because it's not the point of this meeting. We're talking about React. So here's a quick example of how you would potentially change a like H1 or something. You'd have to document, get element by ID, know the ID of the element, and then set its inner HTML to something that you want. Or like adding a click listener to something. Just, it's kind of annoying. And it gets more annoying when you make more complicated things. So why would you want to use something like React or a JavaScript framework? As I mentioned, vanilla JavaScript gets pretty tedious pretty quickly. Frameworks, especially React, I don't know about the other ones, but I'm sure they do the same thing. You can do modular development, which allows you to write a more complicated component, stick it in a file, and then if you want to use that same component again, you just include it in your file, put it there. It's like 3 more lines, and then you have your entire thing. Similar to like a function in C, you take all of your complicated into like a callable thing, and then you can use it again. You can use super powerful libraries and stuff to do stuff for you that you don't want to write because a bunch of other people already did it. And then it's a bit easier to do HTML and JavaScript at the exact same time. You can just include both of them in the same file without needing to use like a script tag and put the JavaScript in that. So it has some benefits there. So React files typically are written in JSX, which is JavaScript extended, which is what the X stands for, which basically all it means is you can add HTML to it without it being weird, and it makes the React components work a bit better. So each JSX file itself is usually one component. So like I said a bit ago, components are like functions, sort of. So you can write your component and then use it. And that's how you make React modular, which is really one of its big benefits.
Would it be fair to call a component a class as well?
Yes, there are actually class components. That is a thing. We're not going to talk about them because they're old, but yeah, kind of like that-ish. So this is the component lifecycle. It's not super important to know all of these methods because the way React is now headed is functional components, which does all of this under the hood for you, so you don't have to worry about it. But it can still be moderately important to understand just roughly how it works. And then, as I alluded to on Nick's question, there are class components and functional components. Class components is how React pretty much started. You would use classes, you'd use all of those lifecycle methods, and then that's how you would change the DOM. But now they're starting to use functional components, which are newer, and they use like I said, they use those lifecycle methods under the hood. And the benefit of functional components is writing them is a lot more straightforward. You don't have to really like think about it in terms of the lifecycle. You just think about it as you're writing it, just what you want it to do, and then you just write it and it does it. It's not nearly as complicated to write. It's much simpler to go back to and understand how it works. So that is how we will be progressing. So an important thing to understand is what the DOM is. It's the document object model, and this is like the HTML gets rendered as the DOM. So like your paragraph tags, your heading tags, your divs, your links, stuff like that, that's all in the DOM. So the way React is powerful is your code, it takes it, then it writes it to what's called the virtual DOM, which is literally the DOM, but like fake. And then it changes everything, and then it compares the virtual DOM to the regular DOM, and then it only updates the things that actually need to be updated. So if you have like an image up on your nav bar that will always be there no matter what, it doesn't have to refetch the image from like whatever server it's hosted on every single time the page reloads. It only, since that image is always going to be there and it's never going to change, React doesn't change that code when other stuff in your DOM changes. So that's why it's much faster and more powerful than if it would just change all of everything in your code. So here, at its simplest, is a component. This is, again, a functional component, so I'm defining it as a function. So my function is hello. Not practice, but naming conventions, that's the word, is you use capital letters for your components just to differentiate them from other stuff and from regular HTML tags. So there's a function and then the parentheses, because I'm only returning stuff and there's no other JavaScript. You'll notice some curly brackets later. And then I'm just returning hello world. So that's my component. It's just a hello world heading. Of course, we want to try to do more than that. So at first glance, you'd kind of hope adding some logic to a component would be as simple as declaring your variable, changing the variable when you click the button, and then boom, you're done. But it's not, again, because the DOM is static. You can't just interact with it straightforwards like this. It wouldn't really know what's happening. So the way we can do this, at least variable-wise, is we use a state. So like I said, the DOM is static, and it doesn't change unless we kind of explicitly tell it how to and tell it to change. So the way we use data is a state variable, which allows when you re-render the DOM, it remembers what was in that variable. Because otherwise, if we didn't use state and just used that this variable I on line 3, when the page re-renders, I would get set back to 0. It wouldn't remember how far you had counted before, so it would always show 0. And that's obviously not how we want this to work. So that's what state does, is it helps remember what that variable is, so that as the page changes the DOM out for stuff you want, the variables you need to stay the same, and then the ones that you change triggers the DOM to re-render. And you can think of a state variable, the way it works is it has a getter and a setter, basically, like from object-oriented and like C# and stuff. So you get your data using the getter, but then you set it with a different function. So because you have to tell it that's how that variable works. And I have an example over here. So there on line 2, I am declaring my count, which is you use it just like a regular variable. That's like your getter in essence. And then set count, which is a random thing I'm defining. It's a function that sets count to whatever I want. So that's my setter. And again, this is just a naming convention thing that it's count and then set count. You could technically name set count whatever you wanted. And then I'm telling it that it's going to use state, which is React's built-in function, and I'm just initially setting it to 0. You don't have to provide a value there. That value can be whatever you want, a number, a string, a boolean, an object, an array, stuff like that. So then here I am using it. I need those curly brackets because it's telling React that I don't want to print count in my heading. I want it to retrieve the value from the count variable and display that. So that's what those curly brackets are doing. It's how you display JavaScript data variables in React. And then here I'm setting count. So when in this button, that's what it is. When you click the button, it's saying, all right, so I'm going to set count to whatever count is +1, and then it passes that into count, and then it re-renders the page, and now it knows what count is, and it updates count back up to here, and now count is 1 more than it was before you click the button. That kind of makes sense?
Could you go over the use state again?
Yes.
So it's a React Native function. What does it do?
So what it does is, it's a great question. I never think about it conceptually like that. I just know you use the state for a variable. That's the important part. If you need a variable that you need to keep track of between re-renders. So like in a function, like when you have a button that say calls a really complicated function, you can just declare variables like normal. You don't need it to use state. But say you are pulling data from an API. You pull data from the API, and then you would set it in a state so that if, say, somebody clicks a button that changes it to light mode, when it sets the state to light mode, that state with all of your API data is still there. And then when the page re-renders into light mode, it doesn't have to refetch from your API and reload the entire page. It just changes the theme up. So that makes sense? So as I mentioned, API calls, that flows perfectly into side effects, which is basically doing anything that isn't directly changing the DOM. Say working with an API, that's a big example, what you'd use it a lot for. So what you would use for this in React, a big hook we use, I'll talk about hooks later, they're not as important for the basics of React, but we use a useEffect hook, which is saying, I'm going to use a side effect, this here code block. So that's kind of what we'll do to make things happen a bit differently. So again, I have this. So here is the useEffect. UseEffect, again, is built into React. Who knows what it looks like? It probably calls some of those lifecycle methods and stuff, but it has two arguments. The first one is a callback function, or a function in general. So I'm just declaring it as an anonymous function. And then I just put whatever I want to happen inside of that function. So here I'm getting weather from some random API that I totally made up, and then I'm setting my state set weather to the data from that API. And then I can do whatever I want with that. But the key thing about useEffect is this dependency array. You want to always include the dependency array, even if there's nothing in it, just make it empty. Because like when we were developing our website, which we built in React, we forgot that on one of these useEffects, and then while we were debugging, we hit Firebase's read limit because it was an infinite loop. It was just always re-rendering the page. So you want to include the dependency array because that tells the useEffect when this thing changes, that means this useEffect needs to run again. But if something changes that isn't in the dependency array, it won't run. So if you omit it, it will always rerun, and then that can cause problems because of the way we're doing things. So in this, it just needs to know, since it's dependent on these two function calls, they're in the dependency array, so if for some reason those functions changed, then it would know that I need to do this useEffect again because the function is different. That also kind of makes sense. Mostly you want to be careful. And I can show when we get into the demo I'm going to do in a little bit. You have to be careful which variables you put in there and how you use the variables, because otherwise you can run into infinite loop problems very quickly. So useEffect and useState are examples of hooks, which is a way that you can reuse logic. So a hook is a function that allows you to more easily use like useState and stuff and stateful logic, and lets you put it in a bunch of components. An example of a hook I've written is like one for working with a user like object. So I have a user hook that always does the same logic and works with the state and stuff, so that I don't always have to include a bunch of code whenever I need to work with a user. I can just include this hook and then use the stuff I've already declared. Like I said, huge benefit of React is modularity. So any component you write, you can put it in other components. So an example would be you write a button that looks how you want it to be. You make your button component, and then you can just reuse that button as like styled button. And then you don't have to restyle every single button on your page. Even though like you could just use CSS for that, but this can make it easier because there's some things you might want to be able to pass to it and stuff. And then with modularity, you need to be able to probably, I would assume, want to pass data to different components, because if you can't pass data, like you use parameters and functions, if you couldn't do that, if you couldn't give a parameter to a function, functions would not be nearly as useful as they are because it would always run the exact same code. You couldn't try to get a different result. And the way in React, our parameters to our functions are props, and you basically use them like an HTML attribute. So you do it like this. Lines 1 to 3 is my component. And inside of my parameters, I'm just giving it a props object, and then I'm saying hello name, props.name, because props is an object of all of your props. And then down below on line 6, then I'm just telling it that the name is Fred, and I'm passing it like a regular HTML attribute. So then when I'm giving that component and I'm passing it Fred, it knows that I need to pass Fred as the name of props, so props.name equals Fred. Oh, look at that. I did highlight lines. Wow. So you can also use this as a way, like a paragraph tag. You have your beginning tag, your closing tag, and then you have all the words in the middle. You can do that too. That is using the built-in React. It's children is what that one is called. So if I define an alert thing like this, and I have props.title, which would be a title parameter, and then props.children, which is the children of my React component. So then, so that children there. And then on that line, the last line, I'm only passing title as an HTML attribute, and then everything else in the alert I'm just passing as if it was like a paragraph tag or something, where I'm just putting all of the words inside of it. And then here's how we could say do some modular stuff. Hello is like a hello world component. You can just include those components from where they are. You use the // because it has to know it's a file on your system and not from a library. And then you just include it how you wrote it. So both of these components, I didn't include any children or anything or any parameters. And since there's no children, they're self-closing. So I have to have that / after the greater than symbol, just so it knows that that's the end of the component. That's a weird thing that you don't do in HTML, but you have to do here. And if you'll notice, I had to put those in a div. Normally you wouldn't have to in HTML, but React can only have one parent element. So that div is the parent element, and then I can put hello and count inside there. I can't have both of them returned. It gets angry. And as I alluded to earlier, you can use component libraries. These can include like a functional library, like one to work with forms, visual libraries, so it provides a bunch of elements like Bootstrap or something like that, or component libraries where it just is a bunch of pre-styled and functional components. It's basically a mix-up of those other two. And basically all you have to do is npm install your library, and then you just include the components from it. So this is from our website. We used a component library called RSuite. And all I'm doing is I'm including loader from the RSuite library, and then I use it according to their documentation. And all of this pages is it's like that spinning wheel, like when you go to load all of our meetings and there's that spinny thingy while it connects to the database. That's what this component does. So the next things that you would want to do if you wanted to look into React is look into it, read some of the documentation, being aware. React's documentation, most of it is still class-based. You want to know that just because they change the way they do things from class-based to function-based, like states work differently and stuff. But you can look at that, read articles, look at examples. But the biggest thing is just go make something, because as I was explaining to Nick earlier today, React is a bit harder to just look at a presentation like this and fully understand exactly how React works, because there's a lot of intricacies. So just go make something. You'll run into bugs, fix the bugs, use Stack Overflow and the rest of Google to kind of figure out how React does stuff. Because it's super powerful and super useful to build really complicated web apps that are more akin to what people used to have to use, like C and C++ to write a cool desktop app. Like, you can learn React, make a cool thing, and then it's just on the web. Any questions before I do a more codey example?
On the using a library slide, line 7, the export default loading.
I never covered export default loading. That's right.
Yeah,
So on all of these components, I think I never included that.
Yeah, it's only on that slide.
Yes.
From what I noticed.
I will cover that as I do this demo, because I have to do it in there too. So it'll be easier to. All right. So what I'm going to do is use this nifty, handy-dandy tool that sets up an entire React project, like base everything for me. Instead of NPM, I'm using Yarn just because it works a bit better. Sometimes it's literally the same thing. It's a package manager. It installs NPM stuff. So all this is going to do is make a super base React directory project for me, so I don't have to set up all of the infrastructure files. It builds them, it writes straight to them, and it just goes straight from the get-go. It's a really powerful thing because it makes starting a project way easier, because instead of typing, I can just sit here and watch it install a bunch of packages, and then that's it. You can ignore all of these warnings, they're not important. You'll notice eventually it will say that it initializes a Git repo, and then when it's done, it makes a commit. So it's automatically set up for integration with Git. As soon as this command is done, I could just push to GitHub and it would be all set up and everything. So there you go, initialized a Git repository. Then it has to do a couple more installs. And now I'm done. So if I go in here, and now all of this is just there. I didn't have to make any of it. I've already got it laid out how they like. So I can just go into my source folder. Here's a bunch of components that they already made for me. It's just that easy. Now I have a React project and I can start working on it. So what I'm going to do is open my directory. And I'm going to make a new file, and it's going to be called counter.jsx. So now I just have this blank file. I should probably make this text somewhat legible. That's good enough. So React is technically a library. So when I was saying how to like include that stuff from our suite, I have to do that with all of my React components too. So I will need useState and useEffect from React. So that's just telling it when I use a useEffect and a useState function so that it knows what the heck is going on. And then I'll just set up my basic function component. And then I will export default counter. So what this is doing is it's telling the rest of JavaScript, or when you include it, it knows what the component is. So when I include counter, why did it do this? So that's what this in React's code somewhere, they would have said like export useState. So that's all I'm doing. And default just means it's the default one, so I don't need these curly brackets. So we're going to make a basically a stopwatch. You click a button, it goes. You click a button, it stops. You click a button, it goes again kind of deal. Now we just have to hope I remember what it is. Oh, what the? So again, I'm setting up a state. By default, I want the time to be at 0. I know I had 3 of them. That's what it is. We need a way to keep track of if the timer is supposed to be started or stopped. So I'm declaring a state that keeps track of if start is true or false. If it's true, that means the timer is running. If it's false, that means the timer is not. And then I am using this state variable. The way setInterval, a built-in JavaScript function for this, works is it returns a value referencing that interval so that I can stop it when I need to. And I need to keep that in the state too so that it knows how to reference it as the page re-renders every time. So there is a basic use effect, and I put in my empty dependency array because if nothing's going to be in there, then I still want to know that it needs to not re-render every single time. So if loop to say if start is true, then you need to do stuff. So like I said, setInterval is just a basic JavaScript function. All it does is it runs this function every single amount of milliseconds that I put here. So 1,000 milliseconds, 1 second. And all I'm going to do in here is hopefully remember what I need to do in here. Haha, I remembered. So normally it could be as simple as something like this, where I'm setting start to whatever start is plus 1. But then notice how down here React is angry because it wants me to include start here. And if I do that, that means whenever start changes, this use effect is going to run again, which will break everything because it will re-render way too many times. Because since this changes start and it depends on start, it's just going to run a bunch of times. I did mean to set time. Yes, I did. But point still stands. If I had time down here, it'd be angry. So the way you get around that because normally you could just ignore time down here. I do need start here for real because it needs to know when start changes from true or false, it needs to know if it needs to run this again. So the way you get around this, instead of just not including it and living with this annoying warning or putting like a comment doohickey down there, is set time accepts a function. And what that function is the parameter you get is the current value of that variable. So in this case, t is equal to time. But since I'm not actually using the specific reference to time, it doesn't cause an infinite re-render loop. So I can just tell it that I want to set it to its current value plus 1. You don't need to use this a lot, only in a case like this, where in the use effect you're specifically updating a thing in there and you don't want to infinitely re-render because that's bad. And then at the very end, we need to remember how to get the access to the interval so that we can stop it later. So I'm just setting my timer state to the interval. And then I'm just going to return ooh, you're right. So there I can reference time specifically, because if I would just type time there, it would just think I want to say the word time, and that's not what I want. And then I want a button that can do something. So what this button is going to do is it's going to set start to the opposite of what start is at this moment in time. So I just put the exclamation in front to negate the Boolean. So if start is true, it'll set it to not true, which is false. If start is false, it sets it to not false, which is true. That's just so I don't have to do a bunch of if-else's and stuff. And then if it is start is true, that means the timer is currently running. So that means they clicked the button while it's going, which means we're stopping the timer. So what I need to do is I need to clear the interval. This is the built-in JavaScript function to stop an interval, and it's going to stop timer. And then I just need to close my button. There we go. Now I have this component that theoretically works first try. But this isn't being used anywhere right now. I could compile my app and it would just not do anything. So I need to get it into this random file that React made for me. And I'm just going to include my amazing typing skills. I'm going to delete this stuff we don't care about. And I'm just going to put my counter component right in here. So this is the page that when the app starts, it will load this. So this start command is when you do create React app, it like includes a package that allows you to start a thing like in development mode. So you can build it, and then if I were to go into my React file and change a bunch of code, when I saved a file, this knows that it's saved, and it will reload your page for you. So most of this styling was the stuff that they provided for me because I didn't write any of it, of course. But theoretically, if I click this button, it'll start counting because it's set start, so then that use effect ran again, and it sets the interval, so every 1,000 seconds it updates count. And then if I click stop, or the button again, then it hits that button function where it clears the interval and it stops. Click start, starts going back up again. It's not a perfect time counter because it always starts a second off, but so there's a simple React project. Wrong way. So that is the end of the React meeting. It was pretty short, I think. I don't know. Yep, never mind. But hopefully that kind of makes sense. If you have questions, feel free to ask me or Blake, even though he's not an officer, or Nick. And then do something with it. Next week, we're doing ICPC, right?
Yeah, we'll recap this past Saturday's competition of ICPC regional comp in Minneapolis. So if you're here for the qualifier recap, it'll be quite similar. We'll go over problems. We'll talk about the differences between, like, we're only allowed one computer and stuff. So yeah, that'll all be next week. So see you back here, same time, same place.